We're now going to spend a little bit of time looking at amino acids. I know that sounds more of a biology kind of term, but it is relevant in chemistry as well, in terms of its structure and the reactions it undergoes. Okay, so let's first of all discuss the structure of an amino acid. You should know that there are 20 types of naturally occurring amino acids. You don't need to know what those 20 are. But you do need to know the kind of general structure of it. If they do refer to a particular amino acid in an exam question, they will specify which one it is. Okay, so you don't need to memorize them. So, structure of an amino acid, or the structure of an alpha amino acid, which is what we're interested in, is where you have your carbon atom in the middle. That carbon atom is bonded to a carboxylic acid, like that. And that same carbon atom is also bonded to an amine, like that. Okay, so an alpha amino acid is where that one carbon is bonded directly to an amine and directly to a carboxylic acid. So that's what makes this an alpha amino acid. Obviously, carbon needs to have 4 bonds. It is also bonded to a hydrogen, and it is bonded to an R group. Now, it's that R group, the identity of that R group, that tells you which amino acid you are referring to. Okay, so in an exam question, they will tell you, so for example, R equals, I don't know, NH2. And then all you do is you replace the R group with that NH2, and that is that specific amino acid that they are talking about. But you don't need to know the R groups, you need to just know this general formula here. They will tell you what that R group is in an exam. Okay, so this over here is the kind of general structure of an alpha amino acid. And as you can see, this one molecule has this carboxylic acid, so it has a carboxyl group. Okay, and it also has an amine group over here. And what this does is it gives rise to the reactions that it's going to undergo. Okay, a carboxylic acid is obviously the acidic part. Okay, it can lose that proton, and that's what makes this acidic. Whereas the amine part, the nitrogen has a lone pair on it, therefore it can accept a proton, and that makes this side of it the basic part. So an amino acid has both an acidic end and a basic end, and therefore the reactions it can undergo are both the reactions with acids and bases. Okay, so let's now have a look at what reactions they can undergo. So we're firstly going to focus on the reactions that the amine can undergo. So the basic part. Okay. So amines, as you know, are basic, and therefore they can react with acid. They can accept a proton. So let's have a look at a reaction. I'm just going to keep the general formula for our amino acid. So in terms of the reaction it undergoes with an acid, so I'm just going to react it with HCl. All it does is it accepts that proton. So the nitrogen lone pair accepts that proton there, and the product that we get is this here. So it's accepted a proton, therefore it's got a positive charge here. Okay, you've still got that chloride ion, so that chloride ion should be near that ammonium part there, because that is giving rise to a salt on this side over here. Okay, so be aware, if you have a carboxylic acid under acidic conditions, so it doesn't actually matter what acid you've got, if it's under acidic conditions, you will always protonate that amine group there. Okay, so if it's under acidic conditions, you will protonate that amine group there, regardless of what the rest of the reactions are doing. You always protonate that amine group there. Okay, so that is how a carboxylic acid can act as a base, because of that amine group there. Let's now have a look at the reactions of the carboxylic acid. So carboxylic acid can therefore, if it's acidic, it can react with an alkali, so, or a base. So therefore let's have a look at the reaction that it undergoes. So again, I'm just going to use the general formula. So now it's this acidic part that is reacting with an alkali, like that. Okay, so acid plus alkali should give rise to salt plus water. So let's have a look at what it makes. So the amine side doesn't do anything. It's now the acid part. So if it's an acid, it will deprotonate like that, and you've got sodium here, so it forms that carboxylate, that sodium carboxylate salt there, and it also releases a water molecule here as well. Okay, so that's the reaction of the carboxyl part with sodium hydroxide to form this carboxylate salt and water. Okay, so that's fairly straightforward. Acid plus alkali makes salt plus water. Another reaction that the carboxylic acid, or the carboxyl part, undergoes, as you know, carboxylic acids react in esterification reactions with esters, to form esters. Okay, so let's have a look again. Generic. Okay, sorry, that's coming off. Like that. So carboxyl groups react with alcohols to form esters. So we can do the same thing here. I'm just going to react it with methanol. Conditions wise, remember, you have to have concentrated acid, so concentrated sulfuric acid. You must heat it. Let's have a look at what that forms here. So in terms of the ester that forms, I don't know if it's going to fit on the screen, but you form that part there. So the alcohol, the methyl group of the alcohol attaches to the carboxylate part there. Okay, like that. I'm just going to draw the rest of it in. Like that. Okay, you also form a water molecule like you do in esterification. Now the thing to be careful of over here, now this is something that people get wrong or they miss out a lot. The conditions that you've got here are acidic conditions. Okay, as we said, anytime you have an amino acid under acidic conditions, you must protonate your amine group there. Okay, so you must do this part over here to balance it, that you need to have a proton on that side. Okay, so some of that acid will take part in the reaction to protonate our amine group of our amino acid, like that. Okay, so amino acids react with alcohols to form an ester at one end, and you also form the ammonium at the other end and a water molecule too.